Hey, welcome back, everyone. And this is the day three of the workshop. And I'm sorry, this day is exclusively for a workshop. So, and the second workshop is being conducted by Stanley, who gave a wonderful talk yesterday. And he sent a list of wonderful questions that we can relate to AI versus human-led AI. So, uh, without waiting much further, let's get started with this. So, yeah, the stage is yours, Stanley.
Hey guys, so happy to be here again. How was uh how was the day so far?
Yeah, cool. So today we had a session on the impact of inflation on traditional science, and we were also talking about the impact on the DeSci space also, because uh, there are a lot of other tokens that have different kind of tokenomics. So we were talking about the finite and the infinite dilution uh, system. So our focus was on the finite distribution of money. So it was a pretty interesting talk. Yeah. So
Oh, that's so important. And obviously, funding in science is I think one of the biggest stumbling blocks generally. So I love that conversation kind of at the intersection of finance and research.
yeah, yeah. So shall we go with the first question that we want to discuss?
I would love that. And Avi, I'm so excited to talk about this topic, for everyone in the audience and listening on stream. I think our topic is AI versus human-led AI, right?
Yes, yes.
And I'm so excited about this topic. And before I kind of pass it over you to start our dialogue, Avi, I just would like to share maybe a quick story about something I saw early in my career that getting a little feedback. Let's see if it sounds like I might have a little feedback. I don't know if there's some speakers there. It's not too bad.
Speaker is a bit too loud.
I mean, if you guys need to hear me and it's the right volume, I can deal with it. And no feedback right now. So anyway, forgive me. I'm professional. I get distracted. Um,
Is it better now?
but anyway, I think I mentioned in my last talk that my first what I think of as my first grown up job was as a principal machine learning scientist for Google, working in the area of language localization. And unbeknownst to me, this was my first DeSci project, and this would have been maybe 12, 13 years ago. Um, it turns out Google relies on an international population of translators to translate their own language. Actually, that's probably not true anymore. It's probably LLMs now. But this was the pre-LLM era where the very best machine translation systems weren't that good. And so the system that I kind of led machine learning research for was pretty fascinating. We sometimes described it as Uber for translation. And so a job would come in, perhaps to translate part of the Google code base, some research documents, sometimes some marketing material. And in order for that to be pushed out to Google's global empire, we had to, translate it into over 50 languages. And we actually had this incredible decentralized system where, the request would come in. The machine learning system that I designed would select the right translator based on a profile of their language proficiencies, and then the text would be dispatched to them to translate. And this was just such an interesting system, and like I said, it was on the order of 50, 60,000 translators all over the world whose work we kind of guided. But it was really surprising some of these sort of secondary effects of releasing this machine learning system into this labor population. We also provided some kind of acceleration tools, and we found that there were some translators who came to rely on these tools too much, and the strength of their translation decreased. And there were other translators who maybe had just a little bit of linguistic deficiency, and the tools were incredibly helpful. And once again, these were much less powerful AIs in a relatively narrow context. But I think the punchline, and then right before I pass it back to you, Avi, is I'll say that um, these systems where human intelligence and machine intelligence intersect are very complex, nonlinear, and very hard to predict. And so I really think this topic of putting humans in the leadership and kind of using human intelligence to align machine intelligence is really going to be critical.
Okay, so the first question that you have uh, listed here is, what are the main challenges in ensuring AI safety when applied to sensitive domains like rare genetic illnesses and cancer?
Absolutely. And I think a lot of these questions and topics we'll go over will kind of orbit around my work at the Stanford Genetics Department and the medical school, where we're working really closely with doctors, patients, and other care stakeholders in exploring, how to make LLMs a safe and helpful tool. But the AI part isn't the hard part. The hard part I've been finding is the human part, and for many different reasons. Um, Many different people have a piece of the puzzle. Doctors have a certain set of experiences and knowledge. So do nurses. So do patients. So do advocates for patients. So do the scientists who study genetic illnesses, and also the scientists who design medicine. And these are just very different people who, sometimes wouldn't even come across each other in their day-to-day flow. The medical system is so complicated. So how do you really get them to sit down at the table and not just share their knowledge, but the kind of reflection of the knowledge of others through what they know? So, for example, um, what a doctor thinks might be important for an LLM to say to a patient with a certain rare genetic illness might be a little different than what a patient thinks is important to hear. And going all around the table, there's just all of these kind of complexly intersecting perspectives where, you really, before you put the data into the system, have to get advice from everybody. Once you put the data in the system and you start to evaluate it, you need to give all the stakeholders a seat at the table for that evaluation. So yeah, it's so fascinating. It really does kind of feel like the hardest part of this problem is the human coordination part. And by golly, doesn't it just feel like a classic DeSci problem?
Yeah. So can we talk about a bit about the hallucinations aspect, since you mentioned? Yeah.
Very happy to. Hallucinations are quite treacherous, I would say, because hallucinations aren't just made up. A model hallucinates when there's strong statistical indications that what it's saying could be true. And sometimes something that's very close to being true or sounding like it's true is even more dangerous than something that's totally false. So, as an example, a lot of times when a model has a piece of information in it extensively, um, it also almost has the opposite extensively. And so sometimes when you're sort of trying to get a model to definitely say one thing, and so you make that a really strong signal in the data or the reinforcement learning, it has a higher chance of saying the opposite. And so, just as one example, one of the illnesses I'm most active working with day to day and most passionate with is called EDS, which stands for Ehlers-Danlos syndrome. And Ehlers-Danlos syndrome is a fairly unusual um, deletion mutation in the tennyson XB gene. And it's sort of a funny one because it's just one little gene with a deletion, but it's like dominoes. It sort of cascades out through the gene regulatory network and causes some pretty profound differences in all sorts of connective tissue formation throughout the body. And then it's incredibly different from patient to patient for reasons we don't totally understand yet. But anyway, it's extremely important for these patients not to overexert themselves. And so in the data set, there's all this information. They shouldn't work out too much. They shouldn't work out too much. They shouldn't work out too much. And wouldn't you know, a lot of times the model will tell a patient, you got to work out hard. Um, and again, there's all sorts of techniques that deal with this. One that I think is very interesting and is a really promising developing part of standard operations is DPO, which is direct policy optimization. And that's where you give the model a fact, and the fact is kind of trained into the model. So that's a really good way to eliminate a hallucination. But at the same time, sometimes you have this feeling with the hallucinations that you're trying to squeeze the last bit of the toothpaste out of the tube, and the more you squeeze it over here, the more it shoots out over there. Um, so, I think here too for hallucinations, the key really is to keep humans in the loop, have humans talking to models, evaluating models. Um, I guess the last thing I would say, and I feel like this is sort of maybe something that would be helpful for machine learning engineers listening. I found that when it comes to model size, there's some important factors. Like I would sort of describe it as um, you don't want a model that's too small, but you also don't want a model that's too big. Because if you have more parameters than what's needed to capture the desired behavior, there's a lot of extra room for it to learn other things, and there's more work involved in kind of factoring out the hallucination. So that would be my answer, kind of rambly, but there's no single answer. It just really does kind of take a lot of work and a lot of human supervision.
So the next question that is mentioned here is, how do you involve doctors in the process of training and evaluating AI models for medical applications? What systems have you developed to facilitate this collaboration? This is a very important question you have raised. Yeah.
No, I couldn't agree more. And you guys, we're at such an exciting moment in history where this game plan is really being worked out for the first time. So, my answer will be very humble, and I'm sure it'll be very different than what I would say in 3 months. Um, and I would start by saying, Avi, we do it very carefully. Um, Gosh, I actually have a good diagram. Maybe I'll see if I can send that over. But it starts with the data, and so for example, right now I'm actually going to share this link. But we're doing a pretty cool project where we are both training with a number of teams, a bunch of medical models for working with Ehlers-Danlos EDS patients, and then we're also going to be developing a system and a platform for evaluating those models. So, like I said, it starts with the data. We have a board of advisors that's helping us select our data sets. It consists of many doctors from the EDS Society, which is the biggest patient care foundation for EDS. We have a number of genetic and medical doctors at Stanford who are helping us select our data sets. And then really just about anyone who has a piece of that puzzle. Like I said, we have patients who have a seat at the table. Um, and yeah, we kind of go through a process where everybody gets to bring a list of the data sets that they think have value. And then we sort of qualitatively evaluate, talk about whether or not this seems like a good data set. We vote, and the data sets that get a majority get put into process. So then a data scientist starts evaluating them for quality, data hygiene, processing them. At that point, we sort of think of what we've created as a data palette. So, we have maybe a couple hundred data sets of many different types, some directly related to EDS, some related to other medical practices. For example, we find that having information about connective tissue disorders generally, um, beyond just EDS specifically, brings a lot of strengths to the model. So we have an EDS dataset module, a general connective tissue module. We have a politeness module because we do find sometimes that when you mix together a lot of this technical jargon, the model stops being quite as friendly. So sometimes you sort of see that, and then you put in a little slice of some colloquial chat data to push it back in the other direction. Um, it's so fun, you guys. It really feels like such a classically experimental process, and again, like it is really exciting to do this when you are sitting at the table with such wonderful, knowledgeable people, and working together. Um, I will share kind of the biggest part of what we're doing and what I'm really excited about. And I might even be terrible. I might even give y'all a piece of homework right now. Um, Avi, have you ever seen Chatbot Arena?
Chatbot arena, you mean the some AI agents like talking to each other and like with some specific goal?
Um, Not exactly, but this is a site you can find, and I'll maybe find it and share the link too. And I would just encourage everybody for your own good and for the good of the whole AI community to go check out uh, this site. Um, and let me pull it up real quick. And spend a little time evaluating some LLMs. This site has access to all of the premier LLMs. And the way it works is you put in a question at the top and you see the results back from several LLMs. And you get to vote on which LLM you think gave the strongest answer. And those results are tracked using something called ELO. Don't know if there's any chess players in the audience, but ELO is a statistical system for tracking performance of different intelligences that are competing with each other. In the case of chess, it's how a chess rating is calculated. And basically, if you play a much stronger player and you win, you get a lot of points. If you play a much stronger player and you lose very few points. And in this way, as chess players are playing each other and their ratings are going up and down, the statistical system will tend to align the chess players according to their performance. And we can do these with the AIs as well. Um, so on Chatbot Arena, you'll see you go in, pick a couple AIs, ask them a question, vote, and then this feeds right back into this leaderboard. And I feel this way, but I would also share that most scientists I work with feel this way. Um, the Chatbot Arena leaderboard is much more valuable than any other system of benchmarking because it does have humans directly in the loop, many different humans with all kinds of perspectives giving feedback. But also, synthetic benchmarks can be gamed. And, I think, for example, we saw, the Claude results, and Claude seems to be much better than ChatGPT on the benchmarks. And anecdotally, for me, I think it is too. But I'm not going to say that real confidently until I see it at the top of a Chatbot Arena. And yes, at Research to the People, we are building our own medically specific chatbot arena system. And so when our teams finish their models, all of our medical mentors, the doctors in our network, and even the patients will log into the Research to the People portal, get a chance to connect to a number of our team's AIs, and then ask them questions and evaluate the answers. And so I feel like this is going to be a very fun platform. And then also in the same way that I, suggested by playing Chatbot Arena yourselves, you'd be contributing to the field of AI by helping, validate and evaluate models. And the same thing for doctors. I personally think that, in a couple of years, it'll be a standard thing that doctors are expected to spend a little bit of their development time talking to models, evaluating them and contributing to the construction of medical grade AIs that are, safe to talk to patients.
Fascinating, fascinating. I'm really looking forward to like exploring that link that you shared just now. Yeah.
Heck yeah.
Yeah. And one question I find very interesting: how do the principles of decentralization and human-led AI align with your work in the medical field?
My goodness, my friend, just so powerfully. And, I think I mentioned a little bit, there's this feeling that there are many stakeholders who have a piece of the puzzle for rare genetic illness. But then there's also a lot of data out there that's incredibly important. There's a number of different institutions that, for example, have, um, DNA sequences from Ehlers-Danlos patients, but they're not really sharing. And, as I alluded to, there's something kind of strange going on in the effect of the, mutation that caused Ehlers-Danlos, like on the rest of the genome. And the first thing we'd have to do to investigate that, to, maybe train a model that would help us to understand that action is, getting all the data in the same place. And there are just so many problems with that right now. We're all familiar with the 23andMe hack. So, with that, a lot of patients and doctors are kind of suggesting that you don't, do your own sequencing, keep track of your own data, which kind of just puts it farther away from all winding up in the same place. Um, and uh, and yeah, I really do think DeSci is the solution. I think that blockchain has the potential to allow people to retain control over their genetic data, for example, while still having the ability to show it to a person to whom they give permission. So in order to get the data organized and constructed that's going to be needed to create these models, I think everyone's going to be talking about DeSci and DeSci principles over the next couple of years.
Okay, so for those less familiar, could you briefly explain what OS LLMs are, the open source large language models and retrieval augmented regeneration or RAG systems are, and how they relate to your work?
Absolutely. Um, I am a major proponent of open source generally and open source language models particularly. In the medical field, probably more than anywhere else as well. Um, what is an open source LLM? Well, it's pretty much the same thing as a closed source LLM. The architecture, which basically means the math that runs these things, is kind of simple. One GPT is pretty much the same as another GPT. It's just a matter of kind of deploying the architecture on a sufficiently large compute cluster, operationalizing a sufficiently large amount of data, and then passing the data through the model and training the parameters. So um, uh, OpenAI has done this, Google's done this, and Meta has done this. But Meta actually released their models. So, you can go download the model, run it on your own hardware, and then potentially change the model, feed the model some new information, get the model specialized in a certain area. And this just creates an enormous amount of power of customization. So for example, the Llama 2 models, the biggest one right now is 70 billion parameters, which is quite a large number of parameters, more numbers than I could remember for sure. But ChatGPT 4, on the other hand, is believed to be well over 1 trillion parameters, possibly more. Um, and like I mentioned before, you want enough parameters, but you might not want more than enough parameters because of cost, because of risks of hallucination, because smaller models are often easier to train with less.
Connection.
Oh, shoot. Out. Sorry, am I back? Forgive me, guys. I'm in a new hotel tonight, and I think maybe the internet is not the best. But anyway, I was just going to say that we're able to get these models that just have less than a tenth of the parameters of ChatGPT-4 to match or exceed the performance of GPT-4 on specific tasks. And so I believe that the ecosystem of open source models is going to be handling a lot of the day-to-day work of artificial intelligence. And, we may only go to these bigger commercial centralized models that utilize the biggest hardware. When we need to, when something really unusual comes up. So that's the answer to the first part of your question. And then the last part was about RAG, which again stands for retrieval augmented generation. Anyone in the audience know what a vector database is? Show of hands, anyone? No problem.
A bit of sketchy idea. Hi, Stanley. Hi. I'm not very well versed about vector space, but I have a bit of a sketchy idea. I think it's more about indexing, like uh, the way Google does the search through indexing some sort of, if I'm not wrong. Uh, so vector search, yeah, mm, they are in like they are hot topic right now.
Oh no, they are. And again, the real punchline, and I'll get to the whole path, but I'll just give you the punchline first. A vector database through a RAG system can give a large language model a long-term memory. And what you said is totally correct. A vector database is a way of using a vector space to create a mathematical index for some type of data. And for everyone else too, you might not know it, but you do have a vector space experience because we are all of us in a vector space right now. At least locally, reality is a three-dimensional vector space. Maybe 3+1, depends what kind of model you're using. But yeah, that just means there's three dimensions, and so all of the points in the space around us can be characterized with three numbers. Um, you guys know that expression, reaching for a word? Like you're trying to come up with a word and you can't quite get it, and you feel like it's somewhere, and you're kind of trying to get it. Um, I personally believe, although we don't really know this yet, that our brain does something like a linguistic vector database, where in some sense, our brain takes our spatial sense and then uses that to organize the relationships of our language. And then for the computers, that's just actually exactly what a database is. It's not a three-dimensional vector space. It's actually potentially a much bigger vector space, potentially hundreds of dimensions. But what happens is a very large amount of text. In our case, this would be medical documents and papers are sort of put into the vector database. So you can imagine literally like you're in a big space and there's tons of words floating around all around you, but not randomly. A very sophisticated system is used so that the geometric relationships between the words as they exist floating in space reflect the linguistic relationships between the words. So these systems actually learn some pretty incredible things. Just for example, vector databases naturally learn the difference between that the difference between man and woman is the same as the difference between king and queen. So queen and king and man and woman, these things vary based on the idea of gender. And so all of the words that vary based on gender are laid out along a certain axis. And so in some sense, you might come to think of that dimension of the vector database as the dimension of gender. So it's very exciting technology. I definitely, obviously, am pretty excited about it. Encourage everyone to go check it out. But yeah, so the punchline is that the same way our brains try to reach for a word, when an LLM is connected through a vector database, through a RAG system, you can literally ask it a question and then it can find the information you need in the vector space. So this is one of the big solutions to hallucination. And then it's also a way to allow a user to access a database using the intelligence of an LLM. But basically, you give it a query, and then it's actually able to go find the answer to that query within this big vector database. It returns the thing that it found. It injects that into the prompt, and then you get back from the LLM the actual specific information. So RAG systems are very important. And I would actually say if you're sort of looking to develop some marketable skills in this area, understanding how to construct a RAG system in a vector database based on some data set is a really good thing to look into.
Wow.
So I was just wondering about there's an initiative called DBio Network. So it's a decentralized bioinformatics and medical network. Uh, it's uh, it's about sequencing genes anonymously and paying in crypto. So they recently made a tweet, very wonderful tweet that it's like a kind of an eye opener. Like as a they've written it in this tweet that as a medical patient or even a casual user, I'm sorry, of online health platforms, data wise, you rarely are your own person. Good news though, with us, you can test your genome in the best object oriented way to become self reliant, the decentralized way. So they have also written kind of a rhyme or a bit of a paragraph. So you are not an object, you are not a subject, you are you, and your data should be yours. Manage your own genetic data and tests on dbio.network. So this was a quoted tweet from one of my tweets in the DeSci India page. So actually, I'm trying to relate this to SLMs, like the small language models and the large language models. So if we want to consider the issue of privacy, so do you think for practicing science, SLMs could be a better choice than LLMs when it comes to doing science in a very like in a private manner, or yeah, like that. Yeah.
I it's I wrote just obviously to give some input, a couple questions. Um, but Avi, that was such a good question. I'm almost surprised I didn't think of it. And I'm so happy to hear about this project. I have it open in a tab now. And I have to say, every time I participate in DeSci events, I learn about such exciting new projects and technologies. And I think this one is definitely on to something. I'm familiar with a couple other projects that are, looking at least similar applications of technology, maybe not the exact solutions. There's a company called My Genome, and then I think there's also Genome DAO. But yeah, the idea of like using cryptographic technology to keep stewardship and agency for genetic data in the hands of the patients, I think is critical. And this also opens up the potential for things like ZK lookup, where you could potentially not share your whole genome, but maybe through a ZK layer or a homomorphic encryption layer, let your genome be checked for maybe a certain illness biomarker without actually having to compromise your data. So yeah, I fully believe that the same way you need to have your social security card if you're in the US, every country has their different kind of administrative document necessities. I really think having your genome cryptographically accessible for your medical professionals will just be part of the hygiene of being a human for too long. And when you get into the question of like, is there a way that large language models could kind of have an interesting application in this situation? I get an exciting moment to plug a new model from some of my colleagues at Stanford, which is called Hyena DNA. And Hyena DNA is the first large language model that's able to learn very sophisticated genomic patterns. Hey, Avi, that DeSci theme song, was that made by an AI or was that made by a human?
A human. An old friend,
Oh, okay.
actually. Yeah.
No, I believe it. And I actually would have been surprised if it was by an AI, because music is actually quite challenging for large language models, which, kind of seems surprising, right? Why is that the case? Well, it turns out that the important patterns that make a song good are not terribly local. I mean, some of them are, but the chorus of a song recurs throughout the song. There's many pattern motifs, is what we call them, that have a very extended radius that approaches the full sequence length of the genome. And it just turns out that traditional large language model topologies just can't really remember enough to see those patterns. This was the case until Hyena DNA. And the team at Hazy Labs, which is a group at Stanford, they came up with something called the Hyena operator. And this is sort of the silver bullet. It's kind of the magic trick for having LLMs that are able to learn genomes. And then something very exciting gets possible. One of my jobs sometimes is to get yelled at by oncologists. I'm just kidding. I love you guys, obviously. But getting yelled at oncologists because we don't have enough data, or the data is not high quality, or it's not labeled properly. And then we have to go kind of contact biobanks, negotiate, do pre-processing on the data, have to negotiate HIPAA and other privacy concerns. So a lot of the time, it just kind of feels like for every 2 weeks we spend actually, designing the payload for a therapeutic, we spend 5 or 6 weeks like doing data negotiation and cleaning. And large language models are very interesting in this context because, one example of a kind of data that's very important in my work is virological data. Because viruses, every time they infect a cell, they leave behind some genetic material. and that often causes cancer. There's a number of cancers. It's estimated 15% of cancers are actually caused by viral junk messing up your genome, and then many other cancers kind of have secondary causes that are virological, or sometimes even a virological sequence is coding in a tumor for various reasons, which means it produces a protein. And that would then be called an oncoprotein because it's a protein that's particular to the tumor, not to the patient's body. And that's exactly what we need to target in immunotherapy. So anyway, it's very challenging to get this virological data on a sort of cancer by cancer basis. And obviously, like, the data sharing is a big part of it. But if you had a very secure and trusted context where you weren't going to share the data, but you were going to train a model on the data and then share the model, you might be able to solve this problem forever and really make sure that doctors are never moving slower than they need to because they don't have data.
Yeah, so that makes me think that I think SLMs, or the small language models, I was reading an article that they are getting more and more efficient, and that makes me think that if we think about the dependency on the hardware, it's also going to be more affordable for doing science. What are your thoughts on that?
I think it's very true, and we're starting to see people do incredible and unexpected things with 7 billion parameter models in particular. And the 7 billion parameter envelope's very interesting because, like, a couple years you'll be running those on your phone, no joke. And so if we really can eventually squeeze GPT-4 level performance out of a 7 billion or slightly bigger model, then that right there is like your own personal AI that's totally secure and on your device that you can carry around with yourself. And there's actually some good evidence that we do have a lot of performance left to get. Avi and the audience too, have any of you guys heard about model quantization?
How to quantize a model?
Yeah, so when we say a model has parameters, that just means numbers. It just means that there's 70 billion numbers that somehow encode the intelligence of the AI. And that's what we do during the training process is basically, I don't know if you guys can picture 7 billion numbers at once, but you almost imagine that these numbers are out here in a big webby blob of the neural network, and then it's almost like the data is pushed through the network. And as the data moves through the network, the numbers change. And so you might think that work is being done to set these numbers at different values. And then what are those values? Like, typically, a large language model might be a 16-bit integer parameter. So 16 zeros and ones worth of information for each parameter. But yeah, there's something really interesting you can do that just works way better than it should. You could take like a 16-bit parameter system, swap it for a 4-bit parameter system. So in some sense, you're throwing away 80% of the information. You're throwing away 80% of the work that was done getting all those numbers, interacting with the data and set to the right configuration. But they still seem to work just as well. And so this is really exciting because when you do this, you're basically cutting the size of a model in a quarter. And that means that you can run the model on like much less powerful hardware. So we do have to remember that like the what is going on inside these models is something we don't totally understand yet. And just based on this evidence, it's probably the case that we're going to learn to extract 10, 100, 1,000 times the performance from the same number of parameters.
I think we need to have some more talk about quantization. I think we're looking forward to it. So,
Go ahead. Sorry.
yeah. So, in your experience, what are the key benefits of having humans in the loop when developing and deploying AI systems?
I would definitely say preventing hallucination and understanding the sort of quality significant modes of failure is critical. So, in the medical case, like, are we telling a patient anything dangerous? Are we telling a patient anything unhelpful or untrue? Those are things that the doctors and the patients know. And so, having the information from them about what kind of mistakes we should be looking for, and then having them involved in identifying those mistakes when they come up, it is absolutely critical. Um, it's interesting to think, though. Is this something that AI could take over, or maybe at least help with? And I think eventually, yes. And I would share something kind of funny. Um, when I have a physician I'm working with closely, and they are asking the model questions, interacting with the model, doing this evaluation, I'm always saving that data. And if you have a sufficient sample of language from an individual, you can do what's called a digital twin fine tuning and actually produce an LLM that sounds and talks just like that person. It's actually kind of fun with students a lot. I have them pick their favorite cartoon character and then train a model that sounds just like it. So we actually did a synthetic SpongeBob, where we had a whole conversation between SpongeBob and Patrick, and it was kind of good, man. I have to say, it almost could have been from a SpongeBob episode. Um, but yeah, so in the future, it might very well be that it's like you have the human intelligence there to kind of kickstart the engine. And then as the data grows, you sort of transfer that over to an LLM and then let the LLM handle some of the volume. But at the same time, it's like it's hard to know that you really should or could trust that without the human evaluation. So yeah, I do think humans play a critical role and will definitely continue to.
This reminds me a bit about human augmented AI and also AI augmented humans. So can we talk a bit, a bit about it?
It's an interesting one. Um, I think the human augmented AI we've certainly been covering. We're talking about building systems and processes for allowing humans to democratically select data for training models, and then creating platforms and interactions for humans to evaluate models in ways that feeds back in the training loop. The AI assisted human intelligence, though, to me, that's even a little more interesting, because I think that obviously it's different from humans to humans, but most humans have areas where they're so much stronger intellectually than other areas, and I think all of us really have the potential for in one of our areas of weakness to get support, and that for that to unlock an unreasonable amount of success, because we do have these very specialized intelligences, many of us, that when unlocked to really run free, can run free. And I will give you guys an example, and this is actually the story that really got me passionate about medical LLMs. We had this one oncologist we were working with who was always stressed out, and she had a migraine every day. But this was a person who showed up to work at 4:30 and was often done at 9 or 10 at night many days, and that was before they got to their paperwork, right? And unfortunately, increasingly, decision makers in medical situations are insurance companies and the policies they set. And doctors can kind of exert themselves to swim upstream, but only with pretty substantial effort. So this doctor was really getting dragged down and having limitations in the patients they could work with because of the volume of paperwork that they had to create, letters to insurance companies, administrative inventories for the hospital system. And yeah, this was like actually a relatively piece of low hanging fruit, right? We could take the database of letters that they'd written. We could take a database of papers on the illnesses they were treating, put that in a RAG system, and basically, like, we took this physician who was spending 2.5 to 3 hours doing paperwork, and now I think it takes her 10 minutes. She pretty much just has to write a high level description of what each letter should look like. She gets it back from the AI. She gives it a quick read, maybe tweaks a couple things. Um, and that's obviously just the sort of initial layer. But there's just so many incredible ways that I think these things are going to unlock a lot of talent. And then, before turning it back to you for the next topic, I would say that actually, in the context of decentralized science, the linguistic support for humans is incredibly powerful. I have an Indian collaborator who I think is maybe the most brilliant quantum chemist I've ever worked with. But this gentleman has very good English, but he does clearly come off as a non-native speaker. And so sometimes I think in his correspondence, his level of brilliance doesn't always come through. And yeah, we were actually able to kind of set up a model that was trained with some custom language for him. And, he almost immediately got a job that was, two levels higher in the FANG ecosystem. But just the start, and I really do think that educational layer of like, how do we let the AI be the ally of a human is one of the biggest interesting questions of the moment.
So I've been thinking about like, and there are many initiatives, and like some corporations are also trying to augment themselves with chips inside their brains. And coming to so coming to the thinking about it, so uh, is it also not possible to do it in a non-invasive way, like to augment ourselves with AI? So I think there are possibilities. So open open question actually. Yeah.
I think that I think that in retrospect, Neuralink will be seen as barbaric for just the reasons you're um, alluding to. That there probably will be non-invasive ways to have a brain silicon information interface. There is a paper that came out recently that just dropped my jaw, you guys. Someone actually took EKG data, kind of brain imaging data, and they trained an LLM that was actually able to produce images of what the person was thinking about from their brain scan data. Which, I mean, doesn't that give you a shiver? um, and yeah, I do think that there are a number of projects that are trying to build really high quality neuroimaging data sets. Actually really privileged to have just started a collaboration with the lab at UCLA that works on something called the Human Connectome Project. And so, yeah, I'm very, very optimistic that that we will have non-invasive brain interfaces, and they will play an enormous role in allowing us to interact powerfully with AI.
Cool, cool. And what advice would you give to researchers or organizations looking to adopt a more decentralized and human-centric approach to the development of AI?
I'm afraid that I have to give a kind of a boring answer, and I think it really comes down to data hygiene and data operationalization, which is a kind of process of taking data of very diverse types and putting it into the data systems that can feed a data hungry LLM. So these would be the vector databases. Often you have a relational data system, and then increasingly, and this is something you'll be hearing more about. These systems run off of knowledge graphs, which are so cool. One of my favorite nerdy topics. Um, but there is this kind of issue of organizing the data where you need to talk to the stakeholders. But then there's also this issue of like kind of understanding the operational purpose of the data. So, just for example, I often work on projects where we're working with, chemical discovery and AI tools for chemistry. And, we often have executives who have never heard of a chiral chain. They don't know what, in silico binding infinity means. And so there really is a need for kind of everyone to not just like write down how the data should be organized, but how the data should be understood. And this is something that we usually call a data ontology. So for organizations looking to get involved in this, I suggest that you do a data audit and then define a data ontology. And in that process of talking to your stakeholders about your data, not only will I think you learn a lot about how it can be used and what kind of task targets are relevant, but yeah, I think you can also learn um, uh, sort of like how the data can sort of be used in service of your organization.
So I'll ask one final question before we can do a question answer session. So, how can the DeSci community contribute to the advancement of human-led AI, and what opportunities do you see for collaboration between the two fields?
Incredible question, and I definitely think that one of the most important things that can happen right now is conversation. It's very important for people who are interested in these things to be talking about them. It's very important for people who, have expertise in different areas, but might not be hearing about these things to start hearing about them. So, I definitely think conversation is a big part of it. But I'm going to go even further, and I'm going to make a prediction, Avi, which is always dangerous. In the same way that right now we have a system of kind of scientific publishing, where humans submit information, other humans review it. I think we will have an open source system of model evaluation for each academic subject. So in space science, in marine science, in biology, in chemistry, there will be a website that you log into that is similar to the chatbot arena link that I shared. And you will have access to all of the publicly trained models on your subject. And you will be talking to them and contributing the knowledge that you have to this greater mind that we are collaboratively training in a decentralized paradigm. And so to get ready for that, like I said, y'all's homework is to go check out Chatbot Arena and quiz some bots.
I'll share it on our Telegram group also. I think it'll be good to share it there. Yeah. So let's open the session for more Q&A. Yeah. Yeah.
Yeah, so I have. So Stanley, I have a very open-ended question. Like, so there's always a philosophical question, a debate of narrow AI as opposed to this general purpose AI. There's also I read an article by Ray Kurzweil and claiming that we'll be having those artificial general intelligence by God knows 2040 or something. So what's your thoughts on that?
Oh man, Mr. Dr. Kurzweil, what an incredible person, and I got to say he's headed for maybe the biggest "I told you so" in human history. Has anyone read "The Singularity is Near," which is a kind of book that was written by Ray Kurzweil? And it is about what we're living through right now, and it was written a long time ago. I think I read it when I was 10 years old, if you'd believe that. And it was actually one of the things that I think made me become an AI scientist. And in this book, Dr. Kurzweil kind of takes the idea of Moore's law and the sort of rate at which before AI, Moore's law was allowing us to, do more and more from an intelligence perspective. And he kind of just extrapolated it in a certain way. And he predicted pretty much that we would be seeing what we are seeing right now. So I definitely think of that book as a good guidebook to what's to come. And yeah, he predicts some pretty incredible things about artificial general intelligence, artificial super intelligence, and he might be right about that. I think it's certainly possible. I do my best not to get too distracted by that because I think with just the tools we have right now there's an opportunity to change the world, to make the world a much better place than we really could have dreamed of. And it might sound a little head in the sky to say that, but these little things where human intelligence is limited, where we're not as able to connect and communicate, as an example, the doctors not having to do onerous paperwork. I really think that all those little things have the potential to add up to just a totally different kind of world. That being said, you know, AGI could come, ASI could come. This could change everything. But I'm a little skeptical. I'm a little skeptical because I'm curious if the amount of intelligence that is producible is limited by the amount of intelligence that exists as created by humans. And so, the idea that these systems aren't actually, smarter than humans, I don't know if that's the right thing to say. But if they're not just a sort of reconfiguration of the knowledge that has already been created and understood by humans, but in sort of a different format and accessible in a different way. And so I sort of myself, we're seeing things superhuman in the sense that it can do something a human does so much faster and automatically. But I don't know that I've actually seen yet a model that really does something that to me exceeds the boundary of human intelligence. And yeah, I'm going to sort of like believe that that's possible when I start to see some things like that.
So you are being conservative, I think. Yeah. Yeah, that's it.
Definitely.
Very good.
Definitely.
Thanks, Stanley. If anyone can add or have anyone.
Yesterday you were talking about cancer.
Yeah, if you can have. Yeah.
Hi, Stanley. Hi. I want to ask one thing, that is, nanobots are used in the treatment of cancer nowadays.
Oh, you're
So,
asking are they or
nanobots are used in the treatment of cancer nowadays. So, can AI means those nanobots, can they be programmed in such a manner that they will dispense the medicines inside the human body according to metastasis?
So,
uh
so
oh,
it's
go
like
ahead, sorry. Yeah.
making nanobots more intelligent with LLMs. So perhaps we could use some
Yes.
APIs to improve the nanobots. So that's what she's hinting at, actually. Yeah.
Absolutely. Are you talking about synthetic nanobots or organic nanobots?
Synthetic.
Okay. Well, I have to say, as fascinated as I am by that subject, I am have not worked directly on data generation or technology for synthetic nano oncology. But immuno-driven, protein-driven, because proteins are nanobots after all. That is an area where I am very excited and yeah, am doing a lot of work on using AI for data generation to sort of tailor custom oncology payloads. I would believe that a lot of what I would be talking about in that direction would apply to synthetic nanobots as well. So, maybe that's just something I'll talk about quickly. There is a treatment that I am obsessed with right now. It's something called an ADC, which stands for antibody drug conjugate. And I like to think about this as a microbiological cyborg in the sense that you are actually taking a set of immune cells from a patient, and then you're genetically modifying the immune cells so that they identify and target metastatic cancers through oncoproteins. And then you're actually attaching that immune cell to a drug payload. So something like a chemo molecule is attached to an immune cell. And then the immune cell is actually able to deliver the chemo molecule directly to the tumor tissue. And so this is roughly chemo without side effects. but the targeting is very challenging. Finding those targetable proteins that are present in the tumor and not the patient, and sort of then telling the antibody, go get them. It takes this really complex data operations. And so, as I kind of mentioned before, there's the potential that without needing to share and expose patient data, we could train models that produce the relevant data. I was actually mostly referring to ADC engineering, where a doctor that would need to go run around to lots of different biobanks to find the right reference data could just feed their patient's genome and the tumor genome into one of these models and get back all they need to configure an ADC.
A great explanation. Thank you.
Okay, so I think we are almost over time. So if we have any more questions that may arise in our mind, we could continue the conversation later on. Yeah. Okay, Jennifer, then we can. Yeah. Thanks so much, Alice.
Thank you guys so much for having me. It was such a treat. You will have to forgive me if I was a little fuzzy. I'm usually an
not
8
at all.
p.m.
It was an amazing
I'm usually
conversation.
I thank you so much, and I myself had a blast too. But yeah, like I said, this is way past my bedtime. But for you guys, I am always willing to stay up. I'm so proud of what you guys are doing and accomplishing. And then Avi, I'm actually hoping maybe we can interview you a little bit on my DeSci show. I would love to just kind of pick your brain about your experience organizing this incredible conference. And I hope it's just the first of many, man.
An ideathon.
That's right. I forget that the conference is a bad word in
Yeah,
DeSci.
yeah. If it's a conference, we wouldn't have gotten these discussions and questions. Yeah, it's a very the informal setting really helps with these conversations. Yeah.
I think you've crushed it, man. It's such a good format, and I think you're just doing a real service to the space. And like I said, I'm just so grateful to have gotten a chance to talk to y'all. Hope you guys have a beautiful day, and I'm gonna go off to dreamland right now.
Thanks so much, Alice. Thanks so much.